Yo, what's good YouTube? How you doing? It's your boy Steven, otherwise known as hks.grc, and yeah, welcome to my channel. I'm going to be creating a lot of new, exciting, GR Corolla content and car content in general, so feel free to subscribe for this new awesome shit. And yeah, man, I'm going to be starting to build my motor. I'm calling this project Project Spice. Ronnie from Speed Labs is going to be working with me on this project. He's going to be building my motor and everything. I'm going to be documenting the whole process, and most importantly, teaching you guys and telling you guys how to build a reliable motor, because there's been issues with this G16. Me personally, my motor blew up 10 months ago, and I'm going to make a whole separate video about this, being transparent about everything. And a lot of my other friends as well, man, they're dropping like flies, as they call it. And it's really scary. And so the only thing I had to do was build it again. I'm not going to give up on this platform. I wanted to build it again from the ground up, reliably and everything. And most importantly, I want to show you guys what you need to do for this. And so feel free to like the video and enjoy the content I'm going to be creating, because I'm going to put a lot of effort into this. And most importantly, guys, there's other than the motor and stuff, I enjoy making content. And so if you guys ever want to reach out to me directly and you guys have any questions, what my part list is or anything, I don't gatekeep around here. So literally DM me on Instagram, hks.grc. And yeah, man, let's dive into this video. No more bullshit. Alright, just pulled up to Speed Labs, hella excited. Let's go pull up and say what's up to Ronnie real quick. But yeah, man, this is the shop right here. Already got a nice Evo out front, GRC, and yeah, man, new shop for Ronnie. Congrats to him, bro. He's been here a minute already, like a few months, but he just moved in. It's pretty crazy. Yep, Ronnie is working on a few GR Corolla motors right here. Short block. Ronnie, say what's up.
What's going on, guys?
Yep. Tell them what are we doing today, Ronnie?
That's Steven's block now. Mains are all torqued up. We're using the Weldspeed mains. They're H11 material. We're using our custom coated bearings on this build. So what we're gonna do now is we've measured out the crank already. Like I said, these are all torqued up now. We got the bearings in there. Now we're gonna measure our main bearing clearance and if everything looks good. Unfortunately, right now we don't have thrust bearings, so we can't complete the short block assembly, but we can get everything measured and make sure it's good to go on those bearings coming from Toyota. We can go back together pretty easily. Cylinder head's already done. We'll take a look at it afterwards. But yeah, obviously short block has to be together before the head gets bolted on. So with that being said, I'm just gonna set up my fixture and then get going on that. So I've already measured the crank. This micrometer's zeroed out to the measurement of the crankshaft. They were all even, so I can just set them. Usually what I'll do is I'll take the measurements and I'll write them down, and then I'll set this to my biggest one, and then I'll clearance it, and then I'll see what the clearance is, and then the number I get I'll deduct or add if it's bigger or smaller than, one journal is bigger or smaller. These are all the same measurements, so again, you just stick with this and it'll give us the measurement. And now what I'm doing is I'm zeroing this gauge to the actual micrometer, which is the journal size, meaning when I stick this in the bore, it'll give us the oil clearance that we have. So 1 and 4 are perfect, exactly where we want them. 2 and 3 are a little bit tight, so we're gonna take the girdle off. We're gonna swap the bearings with extra clearance caps, or shells rather, and then doesn't have enough, so when it expands, it's not going to expand enough essentially, and you might have metal to metal contact. You don't want it to be too big, because then your oil pump can't keep up. Preferably, it would be nice to have it big, because you would have a nice oil fill rather than small, but the oil pump struggles, so that's why we have to stay within a certain range. And it also Depends, platform to platform will vary. Like if this was a Evo cast iron block, I would run about another thousandths more than what I'm running here. Reason being is cast iron doesn't expand nearly as much as aluminum does. So on an aluminum block, if I run the same clearances as the cast iron stuff, it's not gonna work that well. It's probably gonna suffer from oil pressure issues. And that's the last thing we want when putting a new engine together. There's also two ways of measuring this. Some people like to use what's called a Plastigauge, which is this thing right here. So it's a thin film of plastic that it's almost like putty. You'll put it on whatever you're measuring and you'll torque it down and it'll squeeze it, and then over here you have the actual gauge. So say this gets squeezed down. I can't illustrate it right now with my fingers, but let's say this gets squeezed down. Maybe you can come over here and kind of find your reference range. And then so you can match it. So if this was the thickness of this green line, it would be 2/1000ths. About. This is very rough measurements. So Plastigauge is, you know, for like a DIY home enthusiast, it's okay to use a Plastigauge, but you know, when we're dealing with these kind of clearances, yeah, Plastigauge isn't exactly ideal. So.
Just look at all the other motors that Ronnie's currently building. This is another Corolla motor right here, G16. It's crazy, man. Crazy to look at. Here's a cast iron block he was talking about for the Evos. Pretty wild. Yeah, so Ronnie does everything in-house, guys. Look how many lifts he has. Has so many lifts, has so many Evos and everything. Bro is the Evo god. This is crazy. Man, I really want an Evo now. Like, actually. Maybe after the GRC. Maybe this will be the new project. But look at all this stuff, man. Radium, surge tank. Wild, bro. Projects on projects on projects. Car parts on car parts too. Just look at this shit, bro. This is crazy. Bro, I even have my own boxes labeled. Let's go, let's go, let's go. That box is mine, and that box is mine. Full of my old motor parts and stuff that we're gonna use. Reuse some of them, but not all of them. But man, this is really crazy to see. Has a whole nice engine build room. Very nice, very nice. And he has some decontamination filtration system too that helps with you know, the motor building process, so no contaminants infiltrate the motor. Ronnie, so how does this motor assemble? What parts basically complete the motor?
Sure, so this is what we would call your bare block, with the exception of the studs that are in there and the bearings. So obviously you have your main bearings, you have your thrust bearings, which we're missing here, obviously. But that's gonna go on the engine before it goes completely together. We have the bed plate, or the girdle as some call it. The GRC ones are very strong because it's tied into one piece. So it's a very strong piece. So it's the girdle, then crankshaft goes in here, and then when you turn this around, we have the surface of the block. So we also have head studs. You have the good studs from Weldspeed, so the 625s I believe is the ones you got, or the H11s, I can't remember. They're both good for the power you're going to be making, and then some. This block is obviously going to be more than capable of whatever you throw at it. We're going to be using the Vulcan style head gasket. The gasket itself, I'll show you guys real quickly, made by SCE, and it has these steel rings that actually have grooves on them, or high points as I like to call them. They have about 3 of them on each one. So when you put the cylinder head down and you torque it, those grooves bite into the cylinder head, keeping it from lifting under high boost and essentially keeping the head gasket and the head on the block where it belongs. So that's one of the first upgrades that we do on most people that want to upgrade their GRCs. If they want to do cams, springs, anything like that, the head gasket gets replaced automatically. So obviously after that, we have the cylinder head itself. The cylinder heads are about 80% assembled. The only thing we need to do is bleed the lifters, put the rockers in, put the camshafts in, obviously tighten them in sequence, and then time the engine. So the GRC is actually a very simple engine. As complex as it looks, it's actually very simple. So, and it helps that it's 3 cylinders. You know, put 12-cylinder engines together. Obviously, you can see how much time that would take compared to 3. So, whatever work I'm doing, it gets multiplied. On a 6-cylinder, it's, you know, twice the amount of work. On a 12-cylinder, it's 4 times the amount of work. So the piston rings have already been gapped, both the top and bottom rings. We also have the oil control ring pack, which is a 3-piece ring set. So these are your oil control rings, and this is your oil scraper. They go together like so. And this does exactly as the name implies. It controls the amount of oil that's on the cylinder walls. So if you look on the back of them, I don't know if it's going to be able to see, but there's a H part number and then there's an HX part number. They're probably not going to be able to see. So the HX has about, so both top and bottom shells are going to give you 1/1000th of extra clearance. So if you use one shell, it's going to give you half a thou clearance. And yes, you can mix and match. So you can have like one HX here and one H on the bed plate and vice versa. Doesn't hurt anything. It's just giving you the clearance you need. So the studs can be hand tight because we're tightening the nut on the stud, so you don't want to, you know, torque the stud down. It just won't make much sense. When we get together again, we're gonna tighten it one more time. We're gonna torque it to spec, and then we're gonna check our clearance once more. This is why you don't just throw parts together, because you don't know what the clearance is gonna be without checking. So if you get standard bearings and you put them in there, you might be too tight to loose. You don't know. And every engine's a little bit different. From crank to crank, from block to block, there's going to be variances. So I want to make sure you know exactly what you're getting clearance wise. Now on the block side, or anytime we use a stud, whether it's a head stud or a main stud, what we want to do is we want to make sure that the bottom portion of this washer is clean. Clean meaning no lubricant. And then we put the HPL, or the high pressure lube that ARP provides, on top of the washer, on the actual threads of the stud and on the nut. The reason why we don't want it on the bottom of the washer is when I go to torque it, if I have lube underneath, it's gonna turn on the surface and it's gonna shoot the clamp load way up, so we don't put it on the bottom. Sometimes we have to do this like 5 times to get it perfect, but it's what it is.
It's crazy how precise motors have to be. You know?
Yes, they do have to be. The more you do it, the more you kind of get a feel for it. But obviously, these are things you can't measure with your eye, you know, and you can't eyeball it, and you can't measure bearing clearances with feeler gauges. So, yeah, they are pretty intricate, especially when it comes to bearing clearances, because the oil pump can only supply so much flow, and the clearances are essentially what provide the pressure. It's not the oil pump. The oil pump creates flow just like a water pump does, and based on how much clearance you have, how tight or loose, that determines how much oil pressure or how little oil pressure you have. So that's why you have to be within a certain amount. And even though this is a performance engine, we still follow some of the factory guidelines, so we don't want to go too much above what their specification is. And we obviously don't want to be tighter than factory because this is going to make a lot more power than factory, and the components are heavier. Like everything just kind of has to be accounted for. The engine building is not just throwing parts together. You have to account for everything, and it's a recipe of sorts. You know, everything has to work in conjunction for it to operate smoothly and operate for not just a good time, for a long time. You know. So I'm obviously not zapping it, I'm just walking them on, making sure the main girdle is seated. And then we're going to start torquing it again. Torque sequence is also important. We go in 3 stages. These particular studs go to 75 foot-pounds. So 25, 50, 75. And there is also a sequence of torquing, so you can't just randomly start torquing. So if the clearances are where we need them to be, then what we'll do is we'll measure the rod journals. And I've already got the rods torqued up with the bearings in them. And we'll just measure the crankshaft journal, so the 3 rod journals, take our measurements down, write them down, and then zero the gauge the same way to our micrometer, and then we'll check the clearances. So obviously I'm not going to say exactly what the clearances are, but on the rods we go about 1/1000th looser than what we do on the mains. And again, it's just because it's a steel component. I'm not aluminum, so it doesn't expand as much, and it sees a lot more pressure than the mains do. Pressure as far as like combustion pressure goes. Whenever you have combustion, it pushes down, you know, you're throwing 30-40 pounds of boost in there, combustion happens, presses down on the piston. The bearing needs to have clearance to be able to have the oil wedge. It's called the hydrodynamic wedge. It's the layer of oil film between the bearing and the crankshaft. So you need to have a good amount of wedge in there. So you don't want to be too loose, obviously, because then the oil pump can't provide enough, and then you'll have air and oil, and air is not a great lubrication. So in Steven's build, we're using Nitto rods. These are I-beams. These are very strong rods. So we use similar rods in Evos, 800-900 horsepower applications. Actually, that red Evo over there just made 1,002 horsepower on steel rods, I-beams. When it comes to the bearing clearance on the connecting rods, I'm not going to give exact numbers just because of liability reasons, but we usually run about 0.8 to 1 thou looser than we do on the mains on this particular application, because this is a steel rod, so it's going to have less expansion compared to aluminum, and you also need a bigger, or essentially a fuller hydrodynamic wedge, which is the layer of oil that's between the bearing, and the crankshaft. And the reason for that is this thing is being pushed and pulled violently, you know, at high RPMs. You know, 9,000 RPMs is 9,000 times a minute. So a couple times, more than a couple times a second. It's like, so 150 times a second, this thing's going up and down at 9,000 RPM. So that is crazy. That is a lot of mass being rotated and being pulled up and down in 1 second. So because the piston rod assembly is about 1 pound with the wrist pin. So there's 1 pound of weight basically just being flung around at 9,000 RPM. You guys can see how violent it can get. But another reason is the combustion pressure, especially when you start increasing power output. You need more boost, more timing, whatever. You know, you're on ethanol, you're running 30, 40, 50 pounds of boost on some engines. You need that clearance because the pressure will try to push that wedge of oil out. You know, naturally you would want to just, you know, get it out of its way because it's trying to push down on the piston and the rod, and the oil is between the crankshaft and the rod bearing. So that's why you need a bit of a a bit more clearance so you can have a little bit thicker of a wedge, but you can't go too big, because if you do, then the oil pump can't keep up with the supply, and you have air and oil, and air is not a great lubricant, obviously, as everybody knows. So we run it about 1,000ths looser than the mains on this particular setup. And if this was, say, a 4G63 block, the mains would essentially be the same clearance as the rod blocks. We all have our own tricks, obviously, when it comes to that. We have it, you know, leaning a little bit loose and tighter on some stuff, but yeah, aluminum blocks on the mains, you usually go a little bit tighter because aluminum expands. So we don't have to account for that expansion as much as we do on a steel rod, because, you know, it's going to grow and it's going to have the clearance that it needs, but that's not going to grow that much. So anyway, with that being said, we're going to check our clearances again, and if everything looks good, we're going to move on to our rod bearing clearances, and then we can put our pistons and rods together and have it ready to drop in. Obviously, we can't put the crankshaft in because we don't have the thrust bearings, which are going to come in 2 or 3 days. So every couple of times I want to bring it out, measure it, make sure I'm zeroed. So right now I'm not, so I'll make sure I am at 0. So my measurement actually is what I think it is. I'm not guessing. Right there, that's 0 to the measurement of the crankshaft. Exactly where we want it. What I'm going to do now is I'm going to get our rod journal measurements, and after I do that, I'm going to do the same thing. So I'm going to take the micrometer, I'm going to zero it out to our biggest measurement, and then I'm going to zero out the dial bore gauge to my measurement of the connecting rod journal, and then we're going to take this, stick it in the rod vise, or just even over here, measure it the same way with the dial bore gauge, and we'll see what clearance we have. We want about 2.2 to 2.5 on the rod, so 2.5 dial clearance on the rod. So as long as we're in that ballpark, we're perfectly fine. Even 2.2, you know, even on the low 2s, that's fine, but you don't want to be like in the 3s. It's too loose in my opinion for something like this.
Ronnie, what build do I have here with you?
So this is the SPL 800. This is an engine that we're not sleeving because, quite frankly, you don't really need a sleeve system. The sleeves themselves are super thick, so they're strong. As long as you have good components like 2618 alloy pistons, which is what these are, and you have, you know, some solid connecting rods like you do over here, the I-beams, really, you're not limited to anything, especially because it is a small displacement engine, and you have to essentially you will always make power at a higher RPM, so torque doesn't happen down low at low RPMs. They tend to make a good amount of power and take a lot of RPM, which is the saving grace of these motors. And they're extremely over-engineered. But working with these engines, we've seen a ton of failures from LSPI, that's low speed pre-ignition. Essentially what happens is if you run too thin of an oil and it gets super hot, what'll happen is as the engine's operating, the oil will kind of get sucked up into the cylinder through the rings, because the rings have gaps. Obviously you need gaps in the rings, and as soon as it sees any amount of load, especially at, you know, low RPM, high load, low RPM, it'll have a pre-ignition event, not knock. Knock and pre-ignition are very different. Pre-ignition is whenever the spark plug isn't even firing, and automatically there'll be, you know, essentially like an explosion in the cylinder. Knock is different because knock happens after the spark plug's fired, so a secondary flame front will form on its own, and then they'll collide, and you'll get that knocking noise, pinging. That's why it's called pinging or knock. But pre-ignition, you can't detect it, so by the time pre-ignition happens, the engine's toast. So we've seen those failures where the piston literally turns into dust almost. The connecting rods are very strong, the wrist pins are very strong from the factory, but the pistons are lacking in that department. With that being said, I've made close to 500 on Armando's car, and there are a couple other cars that are in the queue, you know, to make over 500 on the stock engine. Our friends at PowerTune Australia, they've made over, I think, over like 770 horsepower before the engine exploded. That's a lot of power, you know, for a stock motor. But yeah, the pistons seem to be the #1 issue. But obviously, if you're replacing pistons, you're not going to keep the stock rods in there. So that's why on Stevens and on SPL 800s in general, we upgrade the main studs, making sure the mains are nice and tight. And obviously they get machined, so it's a perfect circle. So when you have whatever clearance you have it in a perfect circle, which is exactly what you want. The crankshafts, these get 0 balance because it's a 3-cylinder engine. Very odd, but that's how they get balanced. And as you guys can see over here, there's some Mallory added to it. That's a very expensive metal, and then there's some spots that are drilled to get this to be in the balance range as specified by the machine shop, because this is something we don't do. The machine shop handles this part of the operation, but they are balanced. These do have to get balanced. Compression wise, the Nitto pistons these are actually CP, rebranded as Nitto. CP is a great company. Same compression as the Corolla, so these do not get a bump in compression, not that the engine needs it anyway. So yeah, just in general, a lot stronger components. Like I said, the connecting rods can handle 250 horse per cylinder easily, which, you know, you can't even try to make that with that turbo, or even close. But yeah, if you look at the engine from here, from this angle, you'll see that the crankshaft center line is offset to the left. If you look, if I put, this is the center line. You see that? You see how it's offset to one side? Mm-hmm. And if you look, there's even a notch over here. And like I said, the center line is moved this way. So the reason they do this is so on the power stroke, the rod is already at an angle that's at an advantage for easier, essentially, it's easier for the rod to be pushed down when it's already at an angle. That's why this is called an offset hone and offset bore. This is quite a bit. We've been doing this on some Evo engines for a long time now. People that have CNC machines that can bore and hone a block, you can offset bore it, we can offset bore it, you don't offset hone it, but we're talking 5 to 10 thousandths at most if you're going bigger in piston size. Like if you're going 20 over, 40 over, you can maybe do 10, 15 thou of offset, but this is like over ½ an inch of offset, which is another reason why the GRC block is so superior and over-engineered. But yet it has its drawbacks. Like I said, the pistons are extremely weak, so not extremely, but when they fail really bad.
Yeah, you can
It's
see.
the best way to explain it.
You can see the offset for sure.
Yeah. I mean, you can't miss it. Like on an Evo block, you would have to literally take calipers and measure it to like see it. But on this one, it's literally ½ an inch over.
That's crazy.
Yeah, that's for the rod to have more of a favored angle as it's going down. So it's not at a straight angle. So as it's going down, it's already like kind of kicked to the side. So it's easier to make power. It's free horsepower is what it is. So
Free horsepower.
free horsepower, yeah.
It's kind of crazy that each cylinder could have like 250 horsepower. It's like 2 Miatas in one.
Yeah. I mean, you can get up there, but you need a huge turbo. You need nitrous. And,
Yeah.
These engines don't want to make power easily. That's another thing.
They're stubborn.
They are stubborn engines, yeah. But they're good engines. Like I said, in stock form, they're just not as strong as some other engines are. But the block is extremely over-engineered. I mean, 300 something horsepower out of a 1.6 liter is kind of insane.
Really crazy.
It is crazy, yeah. At the same time, they are weak though. They're strong, but they're weak.
And the weak point's the bottom end, right?
The weak point is the piston.
Yeah.
And obviously, they have valve spring issues, so they'll float. The valve springs don't have a lot of pressure on them. All of that is accumulation of trying to get them to pass emissions and be good on emissions, and at the same time they're trying to develop a performance vehicle. So it's a
tough balance.
Well, it's a balance. The engineering department has different segments. One is in charge of say emissions, one is in charge of like actual power output, one is in charge of actual fuel consumption. So you know, they all have to kind of have a say in it, and it has to be like a balancing act. But yeah, they did kind of skimp out on like the cylinder head sealing side, and well, skimp out as in, you know, if you're trying to make more power, you're kind of limited. A good example would be like a BMW, like a S58, like a G80, G series BMWs, or Supras, even the B58s. Bolt-on turbo on my fiance's car, I made 976 horsepower on my dyno, almost 40 pounds, just bolt-on stuff. On a G80, you spend $5,000, $6,000, $7,000, you're making like 750 horse. I mean, you know, those are insane numbers. So they have headroom. They have headroom to make 1,000 horsepower stock form. As far as the long block goes, obviously you need a turbocharger, you need all that other stuff. But these engines in the stock form, at the very least, you need to assess the cylinder head stuff. So that would be head gasket, that would be valve springs, of course. And yeah, the valve chain geometry is very odd as well. So if you're just throwing springs, that's something that I explained to Steven. If you're just throwing springs in there, if you're so close to coil bind, you got to make sure you have the right spring pressure, the right seats. The right way to do it is to measure it. Obviously, if somebody's just trying to do like Kelford Easy Cams or something like that, we can just throw springs in there, a head gasket, no problem. But if we're doing a build of this magnitude, we don't just throw parts together. It gets measured, installed height, coil bind, like all that stuff gets measured before the cylinder head goes together. So very, very important. This is exactly what you want.
Yeah, they all measured out the same. It's good.
All measure out literally to the 10th of an inch, so the 4th decimal place is the same. That's what I like about new crankshafts. Toyota crankshafts specifically, but the new ones. Old ones are kind of all over the place. The new crankshafts are really good.
So what are you doing right here?
So right now what we're gonna do is we're gonna loosen the rod bolts, back them out, maybe about a 1/4 of an inch, and then we're gonna pop them off the dowel so we can take the cap off. One thing to keep in mind, I don't know if people can see, but I have this scribbling tool. I've scribbled number 3, so this means this is rod number 3 and cap number 3. You do not want to mix these up. So if you mix this with like number 2, it'll bind up. It's very important.
What are you listening to?
I'm actually not listening to anything right now.
What do you typically listen to? Podcasts?
Podcast, good.
Really?
Yeah. Very
It helps you lock in, huh?
Yeah. Especially when you're assembling an engine. Aside from, you know, you're locked in, you're taking measurements, you're making sure everything's clean, going together, but you know, sometimes 12, 14 hours goes by without me knowing.
Oh, wow. Good, there's my boy Danny right here.
Guys?
What's up, bro?
How's it going? Good. Over here we got Stefan's engine. I'm sure Ronnie's talked a lot about this, but it's gonna be one badass build, guys. It's gonna be fucking sick.
Stay tuned, bro. Stay tuned.
Stay tuned. These streets ain't ready. The streets ain't ready. One bad GR coming soon.
Spicy as hell.
Like that.
Money.
Okay, so at this point, the rings are gapped. What I'm gonna do, I'm gonna wear my gloves. I'm gonna wipe the rings. I'm gonna dust the ring. You know, not dust. I'm gonna blow off the rings, make sure they're nice and dry, and then I use a Total Seal Assembly Lube. This is called AL8. I use this with a graphite powder on the cylinder to make the rings seat up instantly when you start the car up. So it's a part of our assembly thing that we do now. Obviously, before we put the crankshaft, like I said, we need the thrust bearing and we need to seal the bottom side of the girdle with silicone.
Alright guys, so I just finished editing this video and I want to give a big shout out to all my supporters, man. If you guys love this video, drop a like and comment, and also subscribe if you want to see some more awesome Corolla content, especially revolving around the motor and everything. And my goal here is to be completely transparent. And if you guys ever want to ask me any questions, reach out to me on Instagram at hks.grc. And yeah, man, stay tuned. There's gonna be a lot of juicy content coming out. Shout out to Ronnie for teaching me everything today, showing me everything. Shout out to Danny, you're hella chill, bro. And yeah, guys, stay tuned. There's gonna be a lot of juicy content coming up, and I can't wait to be, you know, showcasing it all to you guys. So yeah, peace.